students. Today I am going to discuss about the emetics. So before going to explain emetics, I am going to say first one example. See, for example, one NEET aspirant has been missed his MBBS seat in 1 mark. MBBS seat in 1 mark. So he has decided to suicide, and he has suicided by administering some toxic substances. So his parents, the student's parents and the doctors is trying to save his life. So how to save his life means the doctors has to remove the toxic substances whatever he taken from the stomach. So these toxic substances should be removed from the stomach. The only way to remove the toxic substances from the stomach is to vomitings. So to induce vomitings, to induce regurgitation process, we are going to use these emetics. So these emetics are medicinal substances, are drugs which are used to induce regurgitation process, through which whatever the toxic substances administered by the patient can be expelled out from the stomach to oral cavity by vomiting. So these emetics are used in poisoning cases. So generally what we think mean that the vomitings are only belongs to digestive tract, because the evacuation of the food substances is going to be happening from the stomach to the evacuation of the stomach is going to be happening. So what we think that this regurgitation process is only belongs to digestive tract, but it is a primary function of medulla oblongata and respiratory system. This regurgitation process or vomitings is controlled by respiratory tract and medulla oblongata. So in this process, the evacuation of the stomach is going to be happening. So the cause of this vomiting should be suffered by the digestive tract. And these emetics also used, and that means these emetics are mixed in low doses in cough preparations to increase the respiratory tract secretions. So these emetics can be used in cough preparations in very low doses, which increases the respiratory tract secretions. And then, so there are some toxic substances which can be removed by body itself. I'll say for this example, while eating any food items or while any drinking, we'll get sneezing. Why we get this sneezing? So whenever the food particles enters into the respiratory tract, instead of entering into the digestive tract, the body itself expels the food substances whatever enter into the respiratory tract by sneezing. Like that, as same as when a person has administered some toxic substances, the body itself can expel these toxic substances through vomitings. But this is only up to limit. Whatever, it is up to limit. But if we take the concentrated toxic substances or more toxic substances, the body can't expel these toxic substances from the stomach. So in those cases, we have to use emetics to remove the toxic substances from the stomach. And then conditions to use emetics. So the patient, after administering toxic substances, the patient should be in conscious state. Then only we have to go for emetics. If the patient is not in conscious state, we should not use these emetics. So first condition is to administer these emetics when the patient is in conscious state, and when the toxic substances remain in the stomach before entering into the intestine, then only we have to use these emetics. If once the toxic food substances enters into intestine, what happens? Whatever the toxic substances enters into intestine, they will be absorbed by the absorptive villi and absorptive cells present in the intestine, and they get circulated all over the body through blood circulation, and there will be no use of these emetics. So emetics should be used when the patient is in conscious state, and these emetics should be used when the toxic substances present in the stomach itself. And then so there are some salts, inorganic salts, which can be administered as an emetic to produce the maximum effect of this regurgitation process. But they should be taken in larger amounts. If these inorganic salts are taken in larger amounts, what happens? The blood pressure levels increases. The blood pressure levels increases. It will be adverse effect. So instead of going to the administrating large amounts of salt, we have to go for emetics. Emetics are inorganic agents which should be taken in lower doses, and it should produce maximum effect. For such example, there are some examples which can be taken. There are some examples for which these inorganic salts can be taken in very low doses, which produces much extent that means it produces extent effect of regurgitation process. For that, some examples I give you. Sodium iodide, potassium iodide, zinc sulfate, copper sulfate, ammonium carbonate, ammonium chloride, ammonium acetate, antimony potassium tartarate, sodium potassium tartarate, so these are examples in which we can use as emetics in very low doses, and which produces extent effect of regurgitation. So, and one should be remembered that in Indian pharmacopoeia there is no mention of any inorganic salts which can be used as an emetics. So, when the patient, other thing I forgot to say you, when the patient is in unconscious state, by administrating toxic substances, when the patient is in unconscious state, we have to go for gastric lavage process. So when the patient is in conscious state, we will administer emetics. When the patient is in unconscious state, by administrating toxic substances, we have to go for gastric lavage process. What happens in gastric lavage process means, first in gastric lavage process, one oral gastric tube is used. So it is a suction valve. So funnel. When the patient is in unconscious state, we have to go for this gastric lavage process. In this gastric lavage process, one orogastric tube is used. In this orogastric tube, one tube will be, it consists of three parts. One is up to here, it is a tube. It is a suction bulb and it is a funnel. This tube is inserted into the stomach through oral cavity, and then by pressing and releasing actions of this suction bulb, whatever the food substances, toxic substances present in the stomach will be expelled out through this funnel. And when the patient, after administrating toxic substances, when the patient's saving chances are 1 to 2%, then we have to go for intravenous administration of these emetics. Intravenous administration. Instead of administrating these emetics orally, we are going to inject into the veins directly. When the patient life-saving chances are 1 to 2%. And in these inorganic salts, in our syllabus, this copper sulfate and then sodium potassium tartrate are two important examples. Now I will discuss these two examples, copper sulfate and sodium potassium tartrate, in brief. So our first important compound is copper sulfate. So copper sulfate, its chemical formula is important compound so its chemical formula is CuSO4. It is a pentahydrate molecule. It's a pentahydrate molecule. And then its molecular weight. Its molecular weight is 249.7 gram per mole. And then its synonyms. So what are the other names of copper sulfate? Cupric sulfate. Cupric sulfate. Its synonym is cupric sulfate. And then storage. How to store copper sulfate? So these copper sulfate should be stored in well closed container or tightly closed container which is free from air, heat and moisture. So it should be stored in well closed container which is free from air, heat and then moisture. So and then storage, synonyms, molecular weight, chemical formula, and then now we have to go for its physical properties. Physical so in first physical properties, so first color. So color of these copper sulfate, how the copper sulfate looks? The copper sulfate looks in deep blue color. It appears in deep blue color, and then its state, how it appears, it is a triclinic crystals. Triclinic crystals. So you know that what is done by crystals, but what is done by triclinic structure mean? So we So triclinic crystal mean so it is a triclinic crystal. Triclinic crystal. Then its solubility. Then it's a solubility. It is soluble in water. It is soluble in water. It is highly soluble in boiling water. And it is slowly soluble in glycerin because of its viscous nature. Because of the glycerin viscous nature, this copper sulfate is slowly soluble in glycerin. Slowly soluble. And it is insoluble in alcohol. This copper sulfate is insoluble in alcohol. It is insoluble in alcohol. And then so it's a taste. Under physical property, taste is also one of the physical properties. So it's a taste. It tastes like a metallic taste. So what is meant by metallic taste? So whenever we consume some antibiotics or hard drugs and antibiotics, so our tongue tastes something. The taste is known as a metallic taste. When we administer some drugs like heart drugs, cardio drugs, antibiotics, and vitamin D capsules, our tongue tastes something. The taste is known as metallic taste. And then its odor, how it smells? It is odorless. It doesn't have any smell. It doesn't produce any smell. Under physical properties, color, stable, solubility, taste, audio completed. Then go to chemical properties. So, chemical properties. So, copper sulfate is a stable compound. It doesn't react with any other compounds. How can we say that it has a chemical properties? As a copper sulfate is a stable compound, it doesn't react with any other compound. How can we say that it has a chemical properties? The copper sulfate doesn't have a property to react, but it can decompose on heating at various temperatures. See, for example, if this copper sulfate is heated up to 60 degrees, it doesn't decompose. It doesn't decompose or it doesn't eliminate any of elements in its structure. But when it is heated more than 60 degrees Celsius, then it is going to lose its two water molecules. If it is heated up to 60 degrees Celsius, it is stable. If it is heated more than 60 degrees Celsius, that is approximately at 100 degrees Celsius, it is going to lose its two water molecules and forms copper trihydrate. Copper sulfate trihydrated molecule. if it is heated more than up to 60 degrees Celsius, it will be stay stable. But if it is heated more than 60 degrees Celsius, that means at 100 degrees Celsius, this copper sulfate going to lose two water molecules and forms copper sulfate trihydrated molecule. And then, if it is heated more than 100 degrees Celsius, approximately at 140 degrees Celsius, it is going to lose its another water molecule and forms copper sulfate dihydrated molecule. One water molecule is lost. So next, if it is heated more than 140 degrees Celsius, that means when it is heated more than 100 degrees Celsius, approximately at 140 degrees Celsius, this copper sulfate going to lose its another water molecule and forms copper sulfate dihydrated molecule. Again, if it is heated more than 140 degrees Celsius, approximately at 200 degrees Celsius, copper sulfate loses its remaining two water molecules and forms anhydrous copper sulfate. Anhydrous copper sulfate salt. So, if it is heated up to 60 degrees Celsius, it is stable, and if it is heated more than 60, that is approximately at 100 degrees Celsius, it loses its two water molecules, and if it is heated more than 100 degrees Celsius, approximately at 140, it forms a copper sulfate dihydrated molecule by losing one water molecule, and then approximately if it is heated more than 140, approximately at 200 degrees Celsius, it is going to form a copper sulfate anhydrous salt by losing its remaining two water molecules. And then, if extra heat is supplied more than 200 degrees Celsius, it is going to form. That means it is going to decompose itself and forms cupric oxide, sulfur dioxide, and water. So, if it is heated more than I'm going to rub. So, if it is heated more than 200 degrees Celsius, it decomposes. So, if it is heated more than 200 degrees Celsius, it is going to decompose as a cupric oxide, sulfur dioxide, and oxygen. This cupric oxide looks like a coal powder, but not a coal powder. It looks like that. Okay, it is a cupric oxide, sulfur dioxide, and oxygen. And then physical properties, chemical properties, and next its preparation. How the copper sulfate is prepared. So, in in laboratory, the dilute sulfuric acid is going to be added in copper granules or copper crystals or copper granules. Whatever you take for example, you take copper granules. To that you have to add dilute sulfuric acid in the presence of air, specifically in the presence of oxygen. It is going to form copper sulfate. So these are copper kernels or copper granules or copper crystals. In the presence of air, that means specifically oxygen, it forms copper sulfate plus two water molecules, copper crystals, sulfuric acid, and then copper sulfate. Okay, preparation completed. Now we have to go for its uses. So how the copper sulfate can be used? So this copper sulfate can be used as an emetic. In the concentration of 300 mg per 30 ml. In the concentration of 300 mg per 30 ml, this copper sulfate can be used as an emetic. But this emetic should be used, this copper sulfate can be used as an emetic under the supervision of well qualified doctors and nurses, because if we consume the more content of copper sulfate, it is going to produce its corrosive property. So what is meant by corrosive property means, if the copper sulfate, the high concentrations of copper sulfate falls on the skin, it reacts with the skin and it can form holes. So it should be preferred, it should be prescribed under the supervision of well qualified doctors and nurses. So and the next use, it can be used as antidote in phosphorus poisoning. So first we have to understand what is meant by phosphorus poisoning. So if we consume elemental white or yellow phosphorus, it is going to produce a disease known as phosphorus poisoning. In this phosphorus poisoning, all the certain organs in our body is going to be affected. So in this case, we can use this copper sulfate as an antidote. Next use, it can be used as an astringent. So what is meant by astringent? See, for example, if you are having some wounds or any scratches on your hand, so if we apply this copper sulfate solution, and it is going to contract the muscles at the place of scratches or wounds, and it prevents the bleeding. That means it contracts and constricts the muscle cells or skin cells, whatever the present on the wound place, and it prevents the bleeding. Okay, it is the work of astringent, and 1.5% of this solution can be used as an fungicide. So 1.5% of copper sulfate solution can be used as a fungicide. What is meant by fungicide? The fungicides are used to prevent the growth of fungus. And then last use of this copper sulfate is, it is an important ingredient of Benedict's and Fehling's reagent. Benedict's and Fehling's reagent. So first we have to know what are Benedict's and Fehling's reagents. So these are the reagents which are used in the estimation of sugars, isn't it? See, for example, they have given some 4 samples containing sugar contents. Different contents of sugar are present in these samples. They have given 4 samples. If we add these Benedict's and Fehling's reagent, one or two drops Benedict's reagent or Verheling's reagent. After heating on a water bath, it is going to produce some colors. If it produces red color, then the sample consists of more sugar. If it produces orange color, the sample contains the moderate amount of sugars. If it produces green color, the sample contains less amount of sugar or no amount of sugars. Like that, these Verheling's and Verheling's reagents are used in the estimation of sugars. So the copper sulfate is an important ingredient of Verheling's and Verheling's reagent. Then we have to go for its assay, copper sulfate assay. So first, what is done by assay? Assay is the analytical procedure which can be used for the estimation of percentage purity of the given compound or given salt. So percentage purity can be estimated by assay. Can be estimated. So copper sulfate is assayed by which method? Oxido-reduction titration. Oxido-reduction, specifically involving iodometric titration. Specifically involving iodometry. So, next, the assay procedure. First, we have to go for principle. So, principle is based upon the unstability of copper cupric oxide. Unstability of cupric iodide. The unstability of cupric iodide, which forms copper iodide and degrades iodine. So the principle of copper sulfate assay is the unstability of this cupric iodide which forms copper iodide and liberates iodine. So this liberated iodine reacts with our titrant sodium thiosulfate and forms sodium tetrathionate, and this copper iodide reacts with potassium thiocyanate and forms copper thiocyanate. I'll explain you in procedure. You will get to know the principle clearly. So, assay procedure. Assay procedure of copper sulfate. So, first we have to take accurate weight quantity of copper sulfate should be taken. Given salt is, the salt should be weight and accurate amount of salt is taken, and it should be dissolved with a sufficient amount of water. In first step, what we are doing, accurate and weighed amount of copper sulfate is taken. It should be dissolved in sufficient amount of water. And in next step, what we are doing, to this solution we have to add excess amount of potassium iodide. And acetic acid. So, if you are taking excess amount means if you are taking 1 gram of copper sulfate, you have to take 2 grams of potassium iodide. That means excess. So, the copper sulfate salt dissolved in water, and to this we are adding excess amount of potassium iodide and acetic acid. In conical flask, the below reactions were going to be happen. So, our copper sulfate reacts with potassium iodide and forms copper sulfate reacts with potassium iodide and forms two forms cupric iodide copper copper sulfate and copper sulfate dissolving in water, and to that we are adding potassium iodide and acetic acid. The below formula, the below reaction were going to be happen. See, 2 copper sulfate plus potassium, 4 moles of potassium iodide, which forms cupric iodide and potassium sulfate. This is a cupric iodide. This cupric iodide is unstable. What I am studying in the principle. This cupric iodide is unstable, which decomposes or which forms copper iodide and liberates iodine. Copper iodide and liberates iodine gas. And then by adding starch indicator, we have to start the titration against the sodium thiosulfate. In third step, what we are doing? By adding starch indicator, the titration is started. Against sodium thiosulfate Na2S2O3. So this liberated iodine reacts with this titrate sodium thiosulfate and forms sodium tetrathionate. O6 plus 2Na. This liberated iodine reacts with sodium thiosulfate and forms sodium tetrathionate and sodium iodide. And next step, this titration should be continued until the appearance of faint blue color. If the faint blue color is appeared, then we have to stop the titration, and then we have to add 2 grams of potassium iodide. After appearance of what? Faint blue color. We have to add 2 grams of potassium thiocyanate, and then we have to again we have to continue the titration. Then continue the titration until the white yellow color appears. White yellow color appears. See, this remaining copper iodide reacts with potassium thiocyanate and forms 2 moles of copper thiocyanate and 2 moles of potassium iodide. Liberated iodine reacts with sodium thiosulfate and forms sodium tetrathionate, and copper iodide reacts with potassium thiocyanate and forms copper thiocyanate, which gives white yellow color. And then .01 ml of 0.1 normal sodium thiosulfate consumes 0.02497 grams of copper sulfate. So 1 ml of 0.1 normal sodium thiosulfate consumes 0.02497 grams of copper sulfate solution. It is an equivalent factor. Then after the total assay process, after performing this titration, we will get to know that after calculation, we will get to know that the copper sulfate percentage purity is 98%. That means this copper sulfate available in almost in pure state is available. It can be available in almost pure state. So next compound is next important compound which is there in our syllabus copy. Compound is sodium potassium tartarate. Sodium potassium tartarate. So its chemical formula is NaKC4H4O6 and it is a tetrahydrated molecule. And then its molecular weight 282 gram per mole. And then its storage. This sodium potassium tartarate should be stored in well closed container which is free from wetness. That means it should be stored in dry and cool place. Well closed container which is free from wetness. That means it is stored in, it should be stored in dry and cool place. Dry and cool place. And then its synonyms. What is the other name of sodium potassium tartarate? So it can be called as Rochelle salt, and as it names, we can invert these two and then we can call it as a potassium sodium tartarate. Instead of spelling sodium potassium tartarate, we can also call it as a potassium sodium tartarate. Rochelle salt and potassium sodium tartarate are the synonyms. And then physical properties. Under physical properties, what is the color? It is white in color or it is colorless. And then state how it appears. Appears as a crystals and granules. Crystals and granules. And then taste. Its taste is saline taste. So saline is nothing but somewhat salty taste. That's taste. And then ardure. How it smells? It is ardureless. And then last finally solubility, in which it can be soluble. Soluble in water. It is soluble in water. And then we have to go for physical properties, color, state, taste, audio, solubility completed. Then preparation. How it can be prepared? It has two methods. Sodium potassium tartarate can be prepared in two methods. First one is by using sodium bicarbonate, and second method is by neutralization of tartaric acid. By the neutralization of tartaric acid and by using sodium bicarbonate, we are going to prepare sodium potassium tartarate. So our first method in the preparation of sodium potassium tartarate is by using sodium bicarbonate. So this includes two steps. In first step, sodium bicarbonate should be converted into sodium carbonate and carbon dioxide and water in the presence of heat. Sodium bicarbonate gets converted into sodium carbonate and carbon dioxide and water in the first step. Yes. In second step, this formed the made sodium carbonate is treated with potassium bitartarate, which is known as cream of tartar. This formed sodium carbonate is treated with potassium bitartarate, which is sodium bitartarate. So The formed sodium carbonate is treated with potassium bitartrate, which is also known as cream of tartar, and which yields sodium bitartrate and carbon dioxide molecule. Next method, neutralization of tartaric acid C4H4 and O6. It also includes two steps. In first step, the tartaric acid is neutralized by using sodium hydroxide, which forms sodium bitartrate. And water molecule. In the preparation of sodium potassium tartarate, in the neutralization of tartaric acid. First, tartaric acid is neutralized by sodium hydroxide, which yields sodium bitartrate, and this formed sodium bitartrate is treated with potassium hydroxide, which forms our compound sodium potassium tartarate. Sodium, potassium, and water. So these preparations are completed, and then we have to go for uses. Uses of sodium potassium tartarate. So first use is, primarily it is used as an emetic. So what is meant by emetics? So emetic is substances which are used to induce regurgitation process, and then it can be used as an laxative. So what is the laxative mean? These are medicinal agents or medicinal drugs, substances which can be used to get relief from the constipation. Then laxative emetic is used in silvering of mirrors. So what is meant by silvering of glass? So what is the first we have to know what is the property of glass. Glass has a property to transfer whatever the light falls on it, whatever the image falls on it, it transfers. It is a transparent in nature. So if we see our image in the glass, we can't visible. It is not visible as in mirror. So this glass is coated with this. One side of glass is coated with sodium potassium tartarate, and it gets converted into mirror, and our image can be visible clearly. So in the preparation of mirrors, this sodium potassium tartarate is used to coat one side. So next important use is electroplating process. It is used in electroplating process. For electroplating process means it is a process which is used to change the physical properties of any metal. For example, this key, it is a key made up of iron. So if this key is used continuously, what happens? After some days, it gets rust by reacting with air, moisture and oxygen present in the air. It gets rust. So to prevent this rust, we are going to coat this key with copper. It is the iron key. It is coating with copper. So it can use. So the rusting of this iron key can be prevented by coating this copper. So it can give long life. This coating can be done by electroplating process. So next, Fehling's reagent. So what is the Fehling's reagent? This reagent is used in the estimation of sugars. So our sodium potassium tartrate is an important ingredient of the Fehling's reagent. That's it. Thank you.